Authentication. Thank you very much.
Thank you. Thank you guys for coming. My name is Tunde. How many people have at least 5 passwords? How many people have so many passwords that they have to use a password manager?
Security conference.
Okay, so this is the amazing part for me. How many people have to use a password to sign into their password manager?
It depends. What's the reason? Keys. Yeah.
Okay, so there are some password managers that you don't need a password for, right?
No, biometrics, so Face ID.
Okay, but quite a number of people still need a password to use their password manager, right?
Yeah.
Great. So, I'm Tunde. I did my MSc in cybersecurity in UE, and every day when I come to school, I needed to log in into one of these, and then I needed to use a password. And then one of the lecturers suggested that I get a password manager, and I realized that I needed a password to use my password manager. So when it was time to work on my thesis, I figured that this is a serious problem. Like, I totally hated having to sign in every time with a really long and complicated password, apart from the fact that I had like over 100 passwords to a lot of things. So for my master's thesis, I worked on a passwordless authentication system, and that's what I'm going to be talking about today. So I've just given you a brief intro about myself. I'm a cybersecurity researcher and also a software developer. And then, why do I need a password for my password manager? And then, why do I have to keep track of so many passwords? Like, I hate passwords. How can I come up with a system that is cool, that is funky, that is that I'm familiar with, to log in into wherever I need to log in without having to use passwords? The system that I developed, I called it Sesame. There's a cartoon, I don't remember now if it's Aladdin and the 40 Thieves or something, where they say open sesame and then they're able to access. So I made up that, I used that as the name, and then that's where I came up with Sesame. So Sesame is according to me, a novel system of accessing your resources without using passwords. And then I use a combination of 3 technologies to achieve this result. I use a combination of biometrics. Now, I am going to assume quite a lot of things, but I also believe that this is a room filled with security people. There are different types of biometrics. There is physical biometrics, like you mentioned, there's fingerprint, there's Face ID. There's also physiological biometrics, how we type, how we talk. So I use a combination of these 2 classes of biometrics, physical biometrics and physiological biometrics, in my system. I use cryptography. How many people have heard about cryptography here? So I use symmetric and asymmetric cryptography in my system, and I use steganography. Anybody heard of steganography? Thank you. Steganography is a cool way of hiding things in plain sight. So I combine these 3 technologies to develop my authentication system. Now, this screenshot that you can see here is what you will see when you are trying to log in into a system into a service using my system. So, for example, currently, if you wanted to log in into a service, you will need to use a username and a password, on the assumption that that service requires a password. However, using the system that I created, you only need to use the username. For example, the username is an email address. So let's assume that UE is a service that has implemented the system. So before now, I needed to type in my UE email address and my password to log in. With this system, when I go into the UI, I just type in my UE email address. Once I do that, I'm going to get so the system is an app. Currently, I've only designed it for Android, even though I can extend it or design it to also work on iOS. So you install the app, you add the service. So for example, you add UWE as a service. In this screenshot, I have another service that I built that's called Hypermatch. So when you log in, you get a prompt on your device, and it gives you all of the details of the device that's trying to log in into your account. So in this screenshot, the name of the service where you're trying to log in. So that means that when you install the app, you can have tons of services. So for example, now anytime I say service, I want you to assume that that service has integrated my system. So for example, UWE, you have a UWE account, you have a Yahoo account, you have a Microsoft account. Whatever service it is that you're trying to log in is going to come up. The browser, the device, all of the information that is trying to log in into your account is going to pop up so that you can verify that you're actually trying to log in. Now, one of the shortcomings of passwords and multi-factor authentications that we read about is notification prompts. So hackers are trying to access your account. They know that you need to verify that you're the one trying to log in. However, because a lot of people are tired of having to approve and approve and approve, they just approve, and then whoever it is that's trying to access your account has access to it. This system helps you to overcome that shortcoming by ensuring that you can physically see where the login is coming from. And I was discussing with my mentor over there. Even if they were trying to hypnotize you to ensure that you click accept and they can log into your account, this system is going to prevent that. So even if you're under hypnosis, it's not going to work if you use this system. Because first thing is, you can see all of the details. Now let's assume that you're on a beach somewhere, sipping some pina colada, and you're tired, you just want to approve it. Once you click on approve, it is still going to prompt you for your fingerprints. So that is where the use of your fingerprints comes in. I am going to go into more details about the other technologies later, but it's just an overview. So it's going to prompt you for it, and then it is after it has prompted you for it that you actually arrive at this screen that shows the one-time password. Now, on the UI where you are trying to log in, you have to enter this one-time password in that UI. Once you enter it and it confirms it, then your login is approved. So this is how it looks like when you're trying to log in to confirm. Now, I'm going to go into the individual technologies that make up this system. I type differently from the way you type, from the way she types. Everybody types differently. So that's one unique thing about our typing patterns. This is a form of biometrics, but it is physiological biometrics. So this system ensures that only you are able to have access to your account. Now, the reason why I used a typing pattern in this system is for the purposes of account recovery. I believe that a number of services, when you are creating an account and you set a password, how many people have been asked to set like security questions in case you lose your account and you have to recover it? Good. Now, again, I was trying to eliminate the use of passwords. However, I was also trying to ensure that in the case that you lose your account, you are able to recover it without having to lose, your mind. So I was trying to think about the most user-friendly way possible to ensure that it is easy for you to recover your account in the case that you lose it. So that is what the typing pattern does. At the point where so again, it is an app that you install on your mobile device. Now, I'm going to walk you through how it's the installation process. When you install the app, it is going to capture your typing pattern. And how it does that is, I have an input field where you simply just type in your email address. It's just your email address. But the deal is, because of how there's a lot of variations in how people type, you are going to type in your email address, say 3 times. So it's just your email address. You type it, it prompts you, type in again, it prompts you, type in again. So after you have typed it 3 times, it now takes you to a screen where you can now add accounts, whatever accounts that you have. Now, the purpose of capturing the email address, your typing pattern, like I explained, is for account recovery. Now, how does this account recovery work? Let's assume that you lost your device and then you need to recover the accounts that you have saved. What is going to happen is, at the point where you are trying to recover your accounts, it's going to ask you to type in that email address that you typed when you were registering the account. At the point where you type in that email address, it will capture your typing pattern. Then it will compare the typing pattern that you provide when you are seeking recovery with the typing pattern that you provided at the point where you install the app. When there's a match, it knows that you are the one. So that means, in cases where a spouse, let's assume that they are partners, and then one party. So I'm just trying to use that scenario to show that even in the scenario where there's some familiarity and some closeness, but somebody is trying to be funny. So if a spouse is trying to access your account without your knowledge, and then they install the app and they claim that they have lost the device and they are trying to install it, it will request them to type in the email address, and then it's going to now try to compare the typing pattern that was captured at the point of recovery with what was captured at the original point where the app was installed. And obviously there's not going to be a match, because I don't think there's any spouse that they have become so into each other that their typing patterns match. Now, the cool part that I've not mentioned again is, how exactly does this thing work really? Okay, let me not get there yet. Now, I've talked about how the fingerprint works. It is at the point where you are trying to either access your account. For example, you are trying to log in. It brings up the prompt. Before you can approve, you are going to provide your fingerprint for the device. That's where the fingerprint part works. The typing pattern, again, is simply for the case of account recovery. Biometrics. The symmetric encryption basically is when you use a single key for both encryption and decryption, symmetric cryptology. The part where asymmetric encryption comes in is actually in the process of logging in, trying to access your services. Symmetric encryption is used basically for the workings of the system. It's not directly related to authentication. It is the asymmetric encryption part that is directly related to authentication. Now, at the point where you are trying to log in into an account, because the app has been integrated with a particular service, when you make a request on a service, your public key has been provided to that service at the point where you create the account. So whenever you create an account, for example, if you create a UE account, there's a private key and a public key that is created for that account. The private key never leaves your device. However, the public key is a public key, and it is sent to that service to inform them that, oh, an account has been created by Tunde. This is his email address for you guys to know who created the account, and this is the public key. So anytime Tunde is trying to log in into the service, you are going to use that public key to sign a message and send it to his device. And then the device will now retrieve the private key for that account and then verify that the message was actually signed by the public key, and then the authentication process. So that's what the cryptology part is. The asymmetric encryption part is what is used for authentication, while the symmetric encryption is actually used for the working on the system on the back end. Are we still following? Thank you. This is the fun part, steganography, hiding things in plain sight. Now, I talked about typing patterns and encryption. We are all used to uploading pictures, taking pictures, sharing pictures. What steganography is used for in this situation is at the point where you are creating an account. you are going to need to upload an image. Now, because there's the chance that you can lose the device and you will need to recover the account, when you create an account and upload an image, what happens is in the image, the public key for the account is embedded into the image. Now, the typing pattern that you provided at the point where you created the account is assigned with an ID. So, your typing pattern is never stored on the device, is never stored anywhere. It is stored in a server elsewhere. However, an ID is assigned to your typing pattern. Now, that ID that is assigned to your typing pattern is encrypted with a key that is managed by the server. That encrypted ID and your public key, the public key for the account you have created, is embedded in the picture. So, when you are creating an account, for example, you are creating a UE account, you enter your UE email address and you upload any picture, well, as long as it's a JPEG or PNG. I've not implemented any other type of picture. I've not implemented GIFs or videos, but a JPEG or a PNG image. So the picture that you upload, you get back the same picture, however, with your public key and your typing pattern ID embedded into it. Now, that picture, you can send it anywhere. Except, well, not a lot of people understand the math or the specifics of how steganography works. So, if nobody knows about steganography, you can just send them the picture. They will not know that there's data embedded in it. But there's data embedded in it. So you can upload it on Facebook, on Twitter, send it anywhere, and then you're fine. The account is created. Now, if you lose that device where the app was installed, and you need to restore the account, you simply, at the point of recovery, upload that image, and then type in the email address that's going to be requested for you. So what happens on the back end is when you upload that image, the typing pattern ID that was embedded at the point where you created the account is going to be retrieved. Do not forget that I said share the image freely, because the truth is, first thing is, your typing pattern is not in the image. It is the ID assigned to your typing pattern that is in the image. But that ID was also encrypted before it was embedded. Now, the other data that was embedded in the image is the public key. But it's a public key, so there's no point in encrypting it. So when you're trying to recover the account, you upload that image, you provide a typing pattern. On the server, we get the typing pattern that you have provided. We get the ID of your typing pattern that is encrypted. We decrypt it. We get the typing pattern that you provided originally, and then we'll compare it. Once there's a match, we know that you are the owner of the account. So again, think about it. I said share the image anywhere. If, for example, you create an account and then you upload the image on LinkedIn, and then because I am tech related and I know about things, I realize that, oh, this is not a random image. It's actually a steg image. Images that have stuff embedded in them can be called steg images. And then I'm trying to recover your account. But the deal is, even if I'm able to retrieve the ID, I don't have access to your typing pattern. Even if I'm able to have access to your typing pattern and my typing pattern will not match. So there is no way that I'm going to be able to access your account. So that is like I believe is a very familiar user experience, because people are used to uploading pictures and sharing pictures. So imagine that now you can retrieve your account with a picture, other than having to use a security question. So that is what steganography does. It's basically to make the account recovery process natural and normal. So imagine if you have pictures floating everywhere. If you lost the device, you don't need... So what I advise is, at the point where you create an account and you get back your steg image, you save it off the device, because it will be double disaster if you lost the device and then all the images. But in the case where you use maybe iCloud, or you have backups, and then you have a way to reach those backups, because again, if those backups are protected by a password and you lost those passwords, then So it saved the pictures somewhere else such that if you lost the device, you are able to get those pictures, and then you just download the app again. Use the process for account recovery, which is simply just upload the image, type in your email address, and then that's it. Okay, so I've already explained how this works. If you are trying to authenticate, you basically go to the service, enter in the email address for the service. You'll get a notification on your device. It's going to go through so at the point where you are trying to log in, the only thing that you require is just your fingerprint. After you have verified where the login is coming from, and then you're able to log in. So that is a summary of the passwordless system that I came up with, and then that's it. So I was trying to get this to production on Google Play Store, but Google has like a system where you have to, first of all, go through internal testing and then a closed phase testing before it goes to production. So I currently have the app on Play Store in beta testing. So if you want to try it, you can scan the app, and then I'm going to get your email address and sign you up for beta testing, and then you can test it. And if you want to connect me, that's my LinkedIn. So if there are any questions, I'll take questions now. Sorry.
Your website is on your Capital. How is the typing pattern stored? You said it was stored something like that.
Okay. So that's the part that I did not mention. So because identification by typing pattern is a huge service on its own, I'm using a third-party service that does this. So basically what I do is when I capture the typing pattern using their library, I capture it. It is encrypted and sent to their server. So they handle all of the creating of identity. Basically, all what my app does is it just assigns a unique ID to your typing pattern.
Yeah, thank you very much for this presentation. For example, my typing pattern when I'm working with my phone is different when I'm typing with my computer. How this is also because I have same apps that I use both on my computer, both on my phone. That's totally different typing pattern.
Exactly.
I've noticed it myself.
Yes, you're actually correct. The same thing that you said, you have a different typing pattern on a mobile device and a different typing pattern on a desktop device. Now, first thing is, this system does not work for desktop. So that means that when we capture your typing pattern on your mobile device, it takes note of the fact that you are using a mobile device. So you cannot, first of all, you cannot even install the app on a desktop device. Now, on the assumption that you even successfully install the app on a desktop device, when it is trying to capture your typing pattern on a desktop device, it recognizes that this is not a mobile device. So there's not going to be a match. But again, that is not going to happen because it is designed, the app is designed for mobile devices. If we're going to get to the stage where we design it for desktop devices, the way by which we'll capture your pattern on the desktop is going to be different. So we'll know. Anytime we are trying to capture patterns, it will let us know that, this pattern is coming from this type of device. So for example, when you use the app on the mobile device, it knows because the typing pattern capture system also identifies the environment where the device being captured is coming from.
We have to stop you there. Thank you very much. That's good.